The production of this program is made possible thanks to the support of the following and viewers like you. Tilting at windmills is an idiom which means attacking imaginary enemies. Windmills, however, are real, and they have real detractors and attackers. Detractors who portray wind turbines, which is their official name, as being an environmental blight that produce little power. There was a modicum of truth to the knock on wind turbines in the 1980s when thousands of them appeared in the San Gorgonio Pass in California. By 1987, there were more than 4,200 wind turbines in the pass leading into Palm Springs that generated between 50 to 100 kilowatts of power each. Today, the total number of wind turbines in the San Gorgonio Pass has dropped to just 666, and they generate 628 megawatts, or enough power to run close to 800,000 homes. Advances in design, construction, power generation, and operation have seen the overall growth of wind-generated power improve. The 9 new wind farms in BC will be home to just 292 next-generation wind turbines that will produce enough energy to run 500,000 homes, which is a substantial increase in power generation over their California cousins. I invited Dan Woynillowicz of Polaris Strategy to join me for a conversation that matters about the truth about wind turbines and the increasing role they're playing in renewable energy in British Columbia. Dan, welcome.
Great to be here.
Windmills, it's interesting when you take a look at the evolution of windmills, which have been around for a long time. It was to move water to in food production, grind grain, and so on. And then somebody, once we had figured out how, with the movement of water over a generator or the spinning of a generator could create electricity, said, why don't we use that wind for other purposes? When did wind power generation really start to take hold? Was it first in the United States or was it in Europe?
In Europe, and then quite soon after that into the United States. And it was really in the 1990s that we began to first see that first wave of proliferation of wind turbines. And as you said in your intro, those tended to be smaller. And so when you thought about seeing a wind farm, it was very dense. You would see a lot of these over a relatively small area of land. What we've seen, though, with the evolution of technology and the refinement of technology is we're getting to much bigger wind turbines with much longer blades. And so consequently, not only can they produce far more power for a single turbine, but they're distributed much more broadly over the landscape. So you don't get that same density as you once did.
So what is the environmental footprint of a single, wind turbine generator? You've got the tower, you've got the blades, but you also have the foundation that it has to be built upon. So what is the overall footprint?
Yeah, so typically when we want to understand what's the full environmental impact of different forms of energy generating technologies, we do something called a life cycle analysis, which is to not just look at the technology itself when it's being used, but to actually factor in everything that goes into it. So all of the materials, the cement, the steel, the production of that cement, the production of the steel, the mining of the iron ore to make the steel. So you look at everything that goes in, and then you look at the operation of the technology itself. And what we find is that looking across renewable energy technologies and nuclear on that life cycle basis, factoring in water use, impacts to water, impacts to species, biodiversity, air pollution, carbon emissions, across all of those parameters that we think of when we think about the environmental footprint of something, these technologies vastly outperform traditional, conventional fossil fuel generation like coal or natural gas. So I think when we think about the impact of these different technologies, we have to start by acknowledging that they all have an impact. And then we have to look at, relatively speaking, which have a lesser environmental impact so that we can get as much of what we want, the electricity, with as little as possible of the impacts that we don't want.
So when we take a look at a new generation wind turbine, What have been the biggest advances, let's say in the last 10 years, that have been able to up the volume of energy that's produced?
So part of it has been about the materials that they're using, which has allowed them to increase the size of both the towers and the turbine blades. The efficiency with which, as those rotors are turning, they can convert that into electricity. So efficiency in terms of being able to produce power, improvements in the materials, and really just getting to those larger sizes, which means that you can produce far more electricity with a single turbine, and therefore you need far fewer turbines to produce a given amount of electricity.
The production of this program is made possible thanks to the support of the following and viewers like you. I have to tell you that I was in the Shetland Islands back in 2008, and they had 4 wind turbines there. I don't know if you've ever been to the Shetland Islands, but the wind howls through there. Like, it howls. And one of the people that I was interviewing said, how often do you think that that turbine generates at full power? And I went, okay, this has got to be a trick question because there's so much wind. I said, I don't know, 75, 80% of the time. And he said, no, actually a little bit less. And it's not because we have too little wind, but we have too much wind. And the blades flex a little bit. But even at 60, 70, 75%, there's a tremendous amount of power that's being generated, especially based on this new technology that you're talking about.
Yeah, absolutely. And so, of course, it's going to depend on the wind resource that you have. That will dictate how often a wind turbine is generating, which is something that we call the capacity factor. So how often is it producing electricity? And for offshore wind, where you do get those large and consistent gales of wind, that's where you're going to have your highest capacity factor and your most consistent production of electricity. When you get to onshore wind, that capacity factor goes down. The wind tends to be a little bit more sporadic in terms of when it comes. But it's important to note that our ability to predict when the wind will be blowing, how much it will be blowing, for how long it will be blowing, has continued to improve over the years. So for electricity system operators who then have to figure out, well, if the wind stops blowing, we need another resource to come in. They have the ability with a high degree of accuracy to be forecasting what's going to be happening. So they're not at the last minute worried about the likelihood of blackouts or of not having enough power. They have the ability now to really understand whether it's the wind blowing or the sun shining, how much they're able to rely on those renewable energy assets, how much power they'll get from that, and then how they can manage the system overall.
Is there a situation where you say, okay, we don't need the power from that wind turbine at the moment, and so then it becomes excess energy? Are we at the point now where we can say, well, it can still continue to produce energy and that energy can be stored? And what are the advances in those storage systems that would allow that to happen?
Yeah, it's a great point. And when we look back to the 90s or even the early 2000s, sometimes you might have a really windy day and you may not have a lot of electricity consumption happening. So you didn't actually need those electrons. And so what would happen is what they call curtailment. So in effect, the wind turbine would be disconnected from the power system so that it's not feeding in electrons that aren't needed. And so that's just wasted potential, right? That's energy that you could be using, but they weren't able to use. But what we've seen now is both in terms of how grid operators can manage the different resources, but then also the advent of various forms of storage, we have the opportunity to, in effect, save that power for later. So, of course, most people will be most familiar with batteries as a means for storage. And we're not just talking about the battery in your phone. We're talking about what they call grid scale batteries. So these very large batteries that if the wind is blowing or the sun is shining and we're producing more electricity than we need, it can be stored in those batteries, and then we can tap into those batteries when we need that power later on. For example, when the wind isn't blowing or the sun isn't shining. There are other forms of energy storage as well. Compressed air energy storage, which uses underground, sometimes it's salt caverns or abandoned gas reservoirs where the gas has been produced, where you can store compressed air. So you compress the air with your surplus electricity, pump it underground. When you need it, you release that compressed air, it spins a turbine and generates electricity. And then you also have pumped storage, which in effect is taking your surplus electricity, using it to pump water uphill into a storage reservoir. And then when you need that electricity, the water is released, spins through a turbine, the typical way we're familiar with hydroelectricity being produced. And again, you get that generation. Or in the case of a system like British Columbia, where we have large reservoir dams, those in effect operate as big batteries insofar as we can turn them on and off or moderate how much electricity they're producing by controlling how much water is flowing through those turbines. And so if we're having a day where we'd be producing lots of wind or lots of solar, we'd be drawing less from those dams. That water would be held back, and then we could use it when we need it later. So we can think of our dams in BC as a real asset in terms of our ability to increase the amount of variable wind and solar that we bring into our electricity system, which allows us to benefit from the relatively low cost of producing wind and solar. While at the same time making sure that from a reliability perspective, we're always going to have electricity when we need it, even when the wind doesn't blow or the sun doesn't shine.
The production of this program is made possible thanks to the support of the following and viewers like you. As you were talking about different storage systems, I was reminded of a couple of different conversations that I've had with Vancouver innovators. One with vanadium batteries that recharge remarkably quickly and have large, as you say, grid scale capacity to store electricity. But then there's also this project that is going on out at UBC where they're using renewable energy, whether solar or wind, during the day to produce green hydrogen and then store that energy as green hydrogen, which and so it goes to show that there's a tremendous amount of flexibility here. One of the other, sorry.
Yeah, I was just going to note that the reality is this is really driving innovation. So sometimes it's about how can we store that energy, or in other cases, it's can we have new types of power use that are flexible so that they can also respond to when we might be in periods of surplus power, they can ramp up operations and use it, or as you say, store it and use it later when we need it. So none of these things are static, whether we're talking about wind turbine technology or battery technology or other technologies, electrolysis to produce green hydrogen. There's innovation happening continuously. There's a real global competition to be able to deliver affordable, reliable, clean electricity. And so there's a lot of interest, both government research and development dollars, but also private sector investment looking at how can we improve all of these things? How can we make them better?
Well, the interesting thing also is if you take a look at, we develop these ways of storing energy, they can then also become export services and products that we can sell internationally, because the reliance on wind energy continues to grow. You take a look at the developments in the Gobi Desert in China. They built a massive wind farm, but it wasn't big enough for it to be able to truly be competing with coal-generated power. And now it surpasses that coal-generated power, and it has become the main source of energy. And China is the world leader in wind-generated power.
Yeah, China has really been leading the way. We tend to just hear about the coal-fired power plants that they have, and they do continue to build some new coal-fired power plants, although they're using their coal-fired power plants less and less. So they may have more, but the extent to which they're relying on them has actually been decreasing. But for China and for many developing countries, they actually have a strong preference for renewable energy because it's technology-based, not commodity-based. Once they buy solar panels or they buy and install wind turbines, after that, the fuel is free. And so they incur that upfront cost, but they're not constantly at the whim of volatile commodity markets where you can have price spikes. And certainly for developing countries, that sometimes means that they simply can't afford to be purchasing that natural gas, for example, for their electricity system. So we're seeing a pivot away from commodities towards technologies. One of the benefits of these technologies is, as we were just discussing, they're constantly improving. And part of that means their cost is continuously coming down. So in most jurisdictions now, the cheapest form of new electricity generation is going to be solar or it's going to be wind. They're going to pair that with batteries, and they're going to be able to get off the roller coaster of these volatile prices for natural gas or for coal if they're reliant on importing coal. So not only are there the environmental benefits, which tend to get a lot of the attention, there are actually economic and energy security benefits associated with shifting away from oil, gas, coal, and onto these new technologies where, as I said, once you own it, the fuel is free. You have certainty as to what your operating costs are going to be, and that has a lot of value.
So if the number of wind turbines in a wind farm is greatly reduced, what does that do as far as the relationship with birds? Because this is something that you hear an awful lot about. When you take a look at that pass through San Gorgonio in California, I mean, it's like there's no way that any flying creature could navigate their way through all those spinning turbines. But with a dramatic drop in number, does this then improve the relationship with our flying, fellow inhabitants of the Earth?
Yeah, absolutely. When you reduce that density, you just reduce the likelihood of there being that collision. We've really come to understand a lot better, where the migratory pathways are for various birds, when exactly they're migrating. We've seen development of new technologies in terms of deterrence, noise, and otherwise, to actually try to make the birds aware that they're heading towards a wind turbine, and so that they can change route. Or else we also have the ability to actually moderate the speed at which the turbine is turning, or to actually stop it from turning in the event that you've got migratory birds that are passing through. And with migration, it happens seasonally. And so again, we have the ability to understand when that's going to be happening, to have those deterrents in place, or to actually even stop those turbines from spinning during those periods. And over the course of the year, that's such a small fraction of the production potential. It only has a marginal impact. So, of course, there are still impacts associated with wind farms and impacts on birds, but we do have the ability to mitigate that as best we can.
The production of this program is made possible thanks to the support of the following and viewers like you. One of the other things that was put to me was, well, a windmill has a lifespan maybe of 20 years, and then that's it. And it was presented in a way that says, and now that site is useless. You've gone and laid down this foundation where you need to put in a pretty massive cement and steel foundation to be able to support this. But that's not the end of that site, is it? If that turbine stops working, it's not as though, okay, we now have to abandon that site.
No, not at all. I mean, I don't see a future in which we're going to be using less electricity. We're going to be using much more electricity. And so what we've seen, and I'm from Alberta originally, and Pincher Creek in southern Alberta, where the best wind resource is, was where we had some of those first wind farms in the early 1990s. Those are now being redeveloped. So you can use the same sites. You may be putting fewer turbines in because they're larger. So you're reducing your footprint. But the reality is, those, particularly those sites that are now coming to their end of life, that, they've been producing for 20 or 25 years, those were typically the best wind resources available. And so those are going to continue to be harvested. So they're going to be redeveloped with new turbines and new technology. So we're going to be able to repurpose those sites as opposed to just abandoning them. It's very different than, say, oil or gas production, where you've got a well, you drill it, you take away all of the resource, and then there's nothing further for you to do for that site other than to hopefully reclaim it, put it back to its natural state. But really, that's the end of its purpose. Whereas, with a wind farm and with this infrastructure, you're going to repurpose it for the next generation of wind farms.
I think you were being generous in your assessment of what happens to old oil wells. There's thousands of them that have been orphaned, and they are a challenge. But it does bring up the question, you talked about the life cycle analysis of a windmill. What are the options in being able to find a post-use base of the blades? Or now, I saw a rather fascinating post that you put up that said the housings for the generators in Europe are now being converted into modular homes. So that's a good repurposing.
Yeah, absolutely. So of course when you're putting so much money into materials, of course, there's a motivation to say, well, what money can we get out of it at the end of life? So when we look at a wind turbine or a solar panel, about 80 to 95% of the mass of that is recyclable or reusable. So we have that potential. Now, we're not necessarily maximizing that potential right now because there hasn't yet been a market for that. But we are seeing a lot of innovation in terms of the materials, our ability to recycle or reuse them. We've got one company that's actually looking at shredding the fiberglass and incorporating it into cement. And then we're also seeing an evaluation of other types of materials other than fiberglass. In Europe, there are two different companies, one of which is focused on the turbine towers and the other is focused on the turbines. And they're using laminated wood products instead of fiberglass. And so, of course, wood at its end of life is going to be recyclable. So that could be an interesting opportunity for British Columbia in the future, given we have a forestry sector, given we've got engineered wood product manufacturing capacity. So we're going to see this continued evolution in terms of the materials, both to enhance performance, but also thinking of end of life and how it can be repurposed. When we look at solar panels, the metals that are incorporated in them are so valuable that you would never just throw a solar panel in the garbage. There's a huge ability. It's far cheaper to recycle a solar panel and to extract those metals than it is to go and develop a new mine to produce raw metals and minerals. So there's going to be an economic incentive to be recycling these things at their end of life.
You were talking about the company that can shred the turbines, the blades. That's another British Columbia company, another innovation that is happening here. And same with the solar panels, and they've got this unique ability to then be able to extract the critical minerals out of what they've shredded on different passes, get that, and then what's left over, as you pointed out, be able to add that into filler for cement. That's a good repurposing. And once again, innovation in British Columbia. We're kind of leading the way in many ways here, aren't we?
Yeah, British Columbia has long been known for its clean tech community and for the entrepreneurship and just capacity for innovation coming out of our universities as well. And really we punch above our weight not only within the Canadian context but even globally. And so I think that's something that we can continue to foster. And part of that is making sure that for these new entrepreneurs, as they're developing new technologies, new products, that they actually have a market opportunity in British Columbia. So can we help foster their growth by being that first commercial deployment, which increases the likelihood that they can successfully scale, and it also increases the likelihood that they'll stay in British Columbia.
Well, thank you for shedding such positive light on the wind turbine generation sector, because I get bombarded by voices that tell me, no, it's a fool's game. After this conversation, I'm happy to have a much clearer picture of what is possible and the continuing innovation that's going to make wind power generation so much more a part of our future.
Great. Well, thanks for the opportunity to chat.
Thank you.